In the name of God, hello dear students, my name is Masoud, I'm a physics teacher. I want to welcome you to Ferkhwa's website. We are here to explain physics curriculum, our plan to make the physics easier for you as much as possible. We try to include some national exam questions, and actually we try to include, let's say, all of the national exam questions during our, let's say, explanation. We solve in each lesson. We solve some of them. If you forget some of them, I'll let's say I'll add it at the end of the section, and let's say I'll solve it for you. Right now, I'm gonna solve the section review 1 to page 18 for you. Question number 1, find the tangential speed of a ball swung at a constant angular speed of 5 rad per second, right? So what's this? This is angular speed, omega. We have omega, and a rope that is 5 meters long. This is r. So omega and r are present, and both of them are 5. As value, they are in value, they are equal. So we look for Vt. What's the rule of Vt? Vt is equal to r omega. Just multiply the value of r and omega. 5 multiplied by 5 becomes 25 meters per second. Question number 2. If an object has a tangential acceleration means AT. AT is equal to 10 meters per second square. The angular speed will do which of the following? The angular speed. So the question asks about the omega. What happens to the omega? Does omega decrease? Does omega stay the same? Does it increase? So this is the question of national exam. It's a nice question. Let me break it down for you. If AT is positive, what does it mean? If AT is positive, let me write the equation for you. AT is equal to R alpha, right? This is the main equation for it. AT is equal to R alpha. If AT is positive, what does it mean? Means alpha is positive as well. And if alpha, so AT is positive, alpha is positive. Because they are interdependent, that's why if alpha is positive alpha means, what does it mean? Means omega f is greater than omega I. What does it mean? Means the object speeds up. So it says the angular speed will do which of the following? Will decrease, stay the same, or increase? Of course, increase. We have a similar question actually, but they changed the sign of the question in a preliminary exam, right? Just they changed the sign. If an object has a tangential acceleration of negative 10 meters per second squared, the angular speed will do which of the following? Preliminary exam, right? Omega will decrease, omega stay the same, or omega increase. Here, negative, we have negative tangential acceleration. What's the meaning of negative tangential acceleration? Let me write the equation of tangential acceleration. AT is equal to R alpha. If AT is negative, alpha will be negative as well. So negative alpha, what's the meaning of negative alpha means? Omega f is less than omega I. What does it mean? Means the object increases its velocity. The object slows down. That's why the object, excuse me, I said increases. The object decreases its velocity. It slows down. That's why omega decreases. Some students, let's say, make the question easy for you, make the answer easy for you themselves, no problem. They don't write this equation at all. They say, teacher, because it says tangential acceleration is positive, that's why we choose increase in velocity. It's right, it's true. And about the negative, they say, teacher, if the tangential acceleration is negative, I choose the decreasing in velocity. No problem, it's true. Without, let's say, writing these equations, without, let's say, interpreting the question, let's say, they find a very easier rule to get the answer. So we accept it, no problem, it's true. So keep in mind that when the angular acceleration is positive, omega is decreased. When tangential acceleration is negative, omega will decrease. That's it. And I prepared one more, let's say, question for you about this one. I changed the, let's say, value. The value of AT is neither negative nor positive. I said that if the tangential acceleration is zero, look here, if an object's tangential acceleration is zero, so there is no tangential acceleration. AT is equal to zero. Let me write it here. AT is equal to zero. There is no tangential acceleration. The angular speed will do which of the following? If tangential acceleration is equal to zero, what does it mean? Means alpha is equal to zero as well. Based on this equation, AT is equal to R alpha. If AT is equal to zero, of course, the radius does not become zero. Radius never becomes zero. That's why only alpha becomes zero. So in this, if alpha is equal to zero, what does it mean? Means omega f is equal to omega I. And if omega f is equal to omega I, what does it mean? Means the object moves at a constant angular speed. So omega stays the same. That's why which option is true? The option B is true. And keep in mind that if AT is zero, so either actually, even if you don't write this equation, even if you don't interpret it, whenever you encounter AT is equal to zero, you can say, let's say omega stays the same, right? Question number 3. Actually, this actual section review contains only 3 questions, but I include 2 more questions for you. They are similar to the question number 2. That's why maybe you say after 2, why there's a, for example, gap between number 2 and 3, because I included 2 more questions. They are very important for us. Question number 3, if a spinning amusement park ride has an angular speed of 1.2 rad per second. So what's this? This is omega. We have omega. What is the centripetal acceleration? So what do we search for? We search for AC, right? AC. What's the centripetal acceleration of a person standing 12 meters? This one is R, from the center of the circular track, right? Omega is 1.2. I summarized it here. R is equal to 12, and we look for AC. It's very easy. AC is equal to R omega square. Just substitute the numbers and find the answer. R 12 multiplied by 1.2 square, and by using calculator, you can find the answer, which is approximately equal to 17.3 meter per second square. So by solving this question, guys, we reached the end of the section 1-2 of chapter 1. I hope you enjoyed this lesson, and see you next video, and bye for now.